Hello, Chem class. Today we're going to be working on a nuclear synthesis, creating one of the transuranium elements. And what they would do here is slam together two different isotopes and hope that some of them stick to each other to make a larger nucleus. We're going to try to figure out which element they made this way. So in order to complete this problem, we're going to first make sure that we obey the law of conservation of mass, which says that, hey, that mass number and that mass number together have to add up to whatever mass number we're going to put over here, and this one as well. So both sides of the equation have to be the same. So when we add up the 209 and the 59, we should get a value of 268. So that means this side of the equation here also needs to add up to 268 for the mass numbers. Now over here we have two neutrons that are formed. So right away that's going to take up 2 of our value here. So this is equivalent to 2, and we have to make it add up to 268. So that means that the new element that we've created must be 266 for its mass number, so that the 266 plus the 2 adds up to the total of 268 on both sides. The same thing has to be true on the bottom numbers, the atomic numbers. So when we add up the 83 and the 26, we end up with a value of 109. So over here, the atomic numbers must also add up to 109. Now in this case, the neutrons do not contribute anything to the atomic number, so this is 0. So this value here on the right for our new element must also be 109. And when we check that on the periodic table, they have now labeled that as meitnerium, and that is named after Lise Meitner, who helped discover the splitting of the atom. So you now have an answer of this right here, and we are done. Over and out.